Welcome back, everybody. We are going to continue on with the review. We're going to do problems 5 through 9 at this point in time. First question up here asks us to find the slope of CD, so that would be this line right here. And since I have a picture of it, I could either do the slope formula or I could just do a little counting. And if I'm going from C to D, I can see that my change in Y would be down 2. So my change in Y is down 2, and my change in X is to the right 4. So my slope then would come out to be negative 2 over 4, and if I reduce that fraction, I'll get a negative 1/2, and that is the slope. If I didn't have the picture, I would go ahead and use the slope formula where my slope is y minus y1 over x minus x1, and in this case, setting this up, my y values would be 1 minus negative 1 divided by my y values. In this case, since I started with this 1, I got to go with the negative 5, so it would be negative 5 minus negative 1 again for my y value, and so I would get 2 over negative 4, which again would reduce to negative 1/2. All right, so if you don't have the picture, you'll have to kind of do the slope formula or draw the picture. And in this case, since I had the picture, I could just count. Now, finding the length, I have to use the distance formula. And so the distance formula, if you remember, is the fact that I'm going to be subtracting my x values and squaring them, and adding my y values and subtracting them from one another and squaring them and putting it all underneath the square root. So, finding the length of CD, I'm going to use the endpoints that I'm given, and from my x values is negative 5, and I'm subtracting away a negative 1. That's why it turns positive, subtracting a negative. And my y values, I would start with the positive 1 and subtract away a negative 1 again and square it. And so then simplifying underneath the square root, it looks like I get negative 4 squared plus 2 squared. And if I square each one of those numbers, I'll get 16 plus 4. And so the exact length for CD is the square root of 20. So then we're going to move on to number 7a here and find the missing angle in this quadrilateral. In this quadrilateral, if you remember, all quadrilaterals add up to be 360 degrees. So if the quad is 360 degrees total for all the angles, then I could just add these up and say 100 plus 80 plus 100 plus the question mark will equal 360. Now, you may remember some properties about that this might be a parallelogram, but if you don't, this would be the way I would go about it. I get 280 plus the question mark equals 360. If I subtract 280 across the equal sign, the question mark comes out to be 80 degrees. And so that's what we were looking for, is that's 80. And so what I was saying is, if you remember your properties of parallelograms, that if opposite angles are congruent, consecutive angles are supplementary. So that's where I could get a few of these, that opposite angles are equal, these two angles have to add up to be 180, or opposite angles are equal, and that would be also 80. That would be another way to get this. Now in this shape, this isn't a parallelogram of sorts, so I have to go through and remember that a quadrilateral is 360, so I'm going to do the same thing I just did over here. I'm going to add up all the angles, 120 plus 95 plus 85 plus the question mark has to equal 360 degrees. It only works for quadrilaterals, so if I add up all of these angles, I get 300 plus the question mark equals 360, and if I subtract 300 across the equal sign, you can see that the question mark is 60 degrees, so that would be 60 degrees up there. Okay, moving along, to find the vertex of a quadrilateral that is defined by these two lines. Well, if I was to draw them, they would intersect, and because they have different slopes. And so what is their point of intersection? Well, I could do substitution using my systems, and so since they're both equal to y, I can set these equal to each other and say negative 3x plus 9 equals x plus 9, and then solve this. So I would subtract an x, And so then that will turn into negative 4x plus 9 equals 9. Subtract 9. And negative 4x equals 0. And if I divide by 4, x is 0. Well, using substitution, I can substitute x in for 0 into either one of these equations to get my y value. And so y equals 0 plus 9, so that means y is 9. So the vertex of the quadrilateral is an ordered pair of x and y. So x and y is where they're going to intersect, and in this case, it's going to be 0 and 9. They want me to write two equations that represent the opposite sides of a parallelogram. And if you remember, the reason we call this the parallelogram is because there's parallel in it. And so opposite sides are parallel in a parallelogram. And so we got to remember what it means to be parallel. And if they're parallel, they have slopes are the same. So the slope of one side will equal the slope of the other side when we're parallel. So that would mean if I'm writing an equation, the only thing that I need to worry about is that the slopes are the same. If the y-intercepts are the same, then they're the same line. So I just got to write an equation that's going to have different slopes, same slopes, but different y-intercepts. So something like, and I can pick whatever slope I want. I'm going to pick a half, and then add 4 for one y-intercept, and a parallel line to that would be the same slope, but a different y-intercept. That's just one example. There's millions of examples out there for that one. And then the last one is write two equations that could represent the consecutive sides of a parallelogram. Well, consecutive sides of a parallelogram, the equations need to have one point of intersection and different slopes. So I'm looking back at example 8 because this was a quadrilateral where we had different slopes, but they had the same point of intersection. And since we're only worried about two equations, I don't have to have anything parallel or anything like that. The word parallelogram could be interchanged with quadrilateral in this case. So what I would do is I could say, okay, I'm going to write an equation with one slope of 1/2 x plus 4. The key was that the y-intercepts were the same. That made sure that I had one point of intersection. So when I write my second equation, I might write something like negative 3x plus 4, and therefore I would have two sides that intersect at the point 0, 4, the y-intercept. Another way, if I needed this to be, say, a square or a rectangle where I had a right angle, then I would concern myself with the slopes a little bit more and make sure that they're perpendicular. So this is just a quadrilateral down here. But if I wanted say a square or a rectangle, then the slopes would be perpendicular to one another, and so I might write it like y equals 1/2 x plus 4. There's my y-intercept, and then I need the perpendicular slope, which is the reciprocal slope of the 1/2, which would be, and changing signs, which would be negative 2x plus 4, and therefore now I have a right angle. These two slopes are perpendicular, and they intersect at the point 0, 4. So it just kind of depends on how they ask the question on that. Well, this concludes our video for this section. I'll come back with more.